All right, let's get right into it. We're going to talk about one of the most critical topics in AI safety today, and that is, how do we build systems that we can actually truly stop in an emergency? We're talking about emergency controls for AI, especially when the stakes are incredibly high.
You know, this line right here, it's really the foundation for this entire conversation. We have to start with the assumption that things will go wrong. It's just a matter of time. So the goal isn't to build a system that's magically perfect, it's to build a system that can fail safely.
And that's really the heart of the matter, isn't it? When something goes sideways, how fast you can react is everything. It is the one thing that decides whether you have a manageable incident or an absolute disaster on your hands. Okay, so to make sure we can respond that quickly, we rely on two key safety tools: escalation paths and kill switches. So let's break down what they are and, importantly, how they're different from just normal day-to-day operations.
Think of escalation like the system's automated, high-tech cry for help. It's not just some random alert popping up on a screen. No, it's a very structured process that says, hey, something's not right, this specific person needs to know right now, and here's all the info they need to make a smart decision. It's got to be automatic and super visible, because trying to escalate manually in a crisis, that's almost always way too slow.
And then you have the kill switch. It's pretty much exactly what it sounds like. It's the big red button. Its only job is to slam on the brakes and stop the system's actions immediately. Now, what's so important to get here is that this is not a last resort. It's not the break glass in case of emergency thing you hope you never use. It is a primary, fundamental safety control that has to be designed in from the very start. And for a kill switch to actually work when you need it most, it needs to have these four properties. It has to be accessible. The right operator has to be able to get to it. Its function has to be unambiguous. You hit it and you know exactly what's going to happen. It's got to be reliable, obviously. And maybe most importantly, it must be independent from the rest of the system's logic, so it works even when everything else is on fire.
So this all leads us to a really core principle here. The more power, the more authority you give an AI system, the tighter and more rigorous its controls have to be. You have to design the response before you grant the authority.
And this slide just lays it out perfectly. Look, for an assistive system, something that's just making suggestions, you might be okay with a slower, manual escalation process. But for an operational system, one that's actually controlling things in the real world, oh no. You absolutely have to have immediate automatic response. The level of control has to match the level of authority.
So you might be thinking, okay, we've designed these great controls. We're good, right? Well, not so fast. Why is it so unbelievably important to test them and test them again and again before you're in the middle of a real emergency? Because here's the hard truth. Untested controls almost always fail, and they fail in ways you just can't predict. The middle of a crisis is the absolute worst time to find out your kill switch takes too long, or the operator on duty doesn't actually have permission to use it, or that your easy rollback plan is actually a complicated mess. Testing is how you find all these gremlins ahead of time. Because in an emergency, simplicity is what's going to save your skin. Okay, so let's get out of the world of theory and look at how this stuff actually gets built. Let's look at a real architectural blueprint for how you'd structure these controls to keep things safe.
Now, what's so cool about this diagram is how it clearly separates the system into three distinct layers, or planes. Down at the bottom, you've got the evidence and audit plane, which is just logging everything that happens. In the middle is the execution plane. That's where the AI and the real-world systems are doing their thing. And then, sitting on top, you have the control plane, where the humans are in charge. This separation is absolutely key to safety.
So check this out. Here's that escalation path in action. If something weird happens down in the execution plane, the system doesn't just guess. It automatically follows this amber path, pushing the issue up through validation checks all the way to the approval gates, right there in the control plane. And that's where a human has to give the final okay.
And there they are, our kill switches, highlighted in bright red. And notice, there are a few of them. An operator can hit stop and halt things directly in the execution plane. Or, from the control plane, they can hit stop/revert, which doesn't just stop the action, it actually rolls it back to a safe state. These are those built-in, no-nonsense safety brakes we were talking about.
So after all that, what does this actually mean for you, for your teams? Well, it means you have a very clear mandate. You have to design for failure. You have to design for when, not if.
And here are your marching orders. First, design explicit automated paths for escalation. Second,
Build those kill switches and make sure they're visible and easy to get to. Third, write down the emergency procedures so there's no confusion in a crisis. And finally, and seriously, this one is so important, train your operators. A kill switch that nobody knows how to use is completely worthless.
I'm going to say this again because it is that critical. These controls can't just be some ideas in a document sitting on a shelf somewhere. They have to be an integrated, tested, living part of the system's architecture. Safety isn't an add-on. It is the foundation you build everything else on top of.
Now let's be crystal clear about what we're doing here today. We've gone over the core principles for designing emergency controls. The idea is to get your teams ready to think through these challenges and build systems that can be shut down safely. But, and this is a big but, this explainer doesn't tell you exactly which tool to use, and it certainly doesn't approve any specific system for use. That's a whole other very rigorous process.
When it's all said and done, it just comes down to this. Building in emergency controls isn't just a technical box you have to check. It's a fundamental responsibility. Thinking about this stuff from day one isn't a chore. It's how we protect our people, our products, and our entire operations for that moment when things inevitably go wrong.